Your textbook has the definition of a rational function, where you have a polynomial function in your numerator and a polynomial function in your denominator. And now we're going to look at the characteristics to help us graph. The first thing we're always going to do, well, as a preliminary, we're going to factor. We're going to factor our polynomial, or our rational function as much as we can, so that we can look at our denominator and determine what the non-permissible values are. In this case, it's factored, x can't be 3 and x can't be -1. Because if it's 3 or -1, you'd be dividing by 0. Now the question...
Hi, sorry to interrupt.
Hello? So we look at our non-permissible values, and our non-permissible values will either be wholes or asymptotes. So the first thing we have to decide is what's going to happen to 3 and -1. If the factor cancels out, that's when you're going to have a hole in your graph. If the factor doesn't cancel out, as in this case, you're going to end up with horizontal asymptotes. So in this case, it doesn't cancel out, and so we have, I'll draw it in here with red pen, an asymptote at x equals 3, and another one at x equals -1. Okay? Now the entire graph is there, so I'm going to remind you that this is group 3. Can you see that the degree is bigger in your denominator than it is in your numerator? Anytime you have the degree larger in your denominator, you will also have a horizontal asymptote at y equals 0. But that's coming up later as another characteristic. I'm just reminding you of that right now. Now they also give us an example of where a factor, x minus 3, simplifies. And then once it simplifies, you rewrite your new equation, which ends up just being y equals x plus 1. This is the situation there's going to be a hole or point of discontinuity. So I'm going to almost always call it a hole. I'm almost always going to write hole at and then say the coordinates when I do my teaching. The proper word is point of discontinuity, which takes like an hour to write out because it's so many letters. But if that shows up on your final exam, you know that point of discontinuity is the same thing as a hole. So our non-permissible value here is 3. And so our equation, we graph y equals x plus 1. And we have a hole when x is 3. To find the y coordinate of that hole, you just have to plug in 3 into your new equation. What's 3 plus 1? It's 4. So the coordinates of my hole are 3, 4. So what happens if you have a hole? You write out your new equation, and that's the one you're going to graph. So you sort of start over again and say, now I'm just going to graph y equals x plus 1. Well, that's an easy straight line. But in my graph, I have to add the hole that I have with it. So characteristic 1 is just looking at the non-permissible values. After you factor, you would always do that first. So here's a couple more examples that they have. They have x plus 3, x minus 3 over x minus 3 squared, x plus 1. So in this example, they want to say, hey, one of these x minus 3's cancels out with one of them on the bottom. Normally, that would make a hole. But now that it's canceled out, you start again and say, how do I graph this? Well, when I'm looking at that, that has non-permissible values at 3 and -1 that don't cancel out. So in my green squared graph, because they don't cancel out, I have an asymptote at x equals 3 and an asymptote at x equals -1. Because one of the factors x minus 3 canceled out, but not all of them, there doesn't end up being a hole at x equals 3. Because x equals 3 is still a non-permissible that shows up in your simplified version, and so it stays as a vertical asymptote. So let's look at our first example here. Now, for each of these, they just look at, in this question, one topic, the vertical asymptotes or the holes. But for each of these, we are going to graph them completely. So I'm going to start off right away by just writing out the steps that you need to graph these completely for any of the functions that you would have. Step 1, factor everything. Okay? After you've factored everything, next thing you're going to look at is your non-permissible values, which is what characteristic 1 was. And you're going to determine, are they holes or are they vertical asymptotes? I'll write that out, but I'm going to abbreviate it later. Vertical Step 3, which we're going to learn at in characteristic number 2. But step 3, you're going to do all of your horizontal asymptotes or oblique asymptotes. You're going to find out, are there horizontal asymptotes? Are there diagonal asymptotes? Step 4, it's always nice to put in some nice points. And then we're going to finish by drawing our graph. So I'm going to put our steps off to the side. So let's look at this one. It says just define vertical asymptotes or holes, but we're going to graph it completely. So really, what this question is looking at when they say that is they just want you to look at step number 2. But we're going to follow through all the steps just so that we can see what the final graph looks like. So in part A, can we factor this? Yes. The top is a difference of squares. So step 1 is factored. List your non-permissible value. Our non-permissible value, x can't equal -5. That would make us divide by 0. Now in this case, the x plus 5 factors cancel out. So our new equation is x minus 5. And what's going to happen with our non-permissible value then? It has a hole at -5, comma, and to find the y-coordinate of your hole, you just plug it into your new equation, -5 minus 5, -10. If your equation simplifies, which it did, our equation simplifies to y equal x minus 5, that's what you would graph. So in this case, when we go to graph this one, x minus 5 has a y-intercept of -5, a slope of 1. You know how to graph a line already, so you just have to graph your straight line, but you have to add the coordinates of your hole to your graph. For part B, did I go up too fast? Everybody good? Again, we start by factoring. The top, you could factor out a common factor of 2, leaving you with 2x plus 1 over x minus 2. Our non-permissible value, x can't equal positive 2. Okay? When we write non-permissible values, we write x can't equal. In this case, this is going to be a vertical asymptote. When we write the equation of an asymptote, it's an equation, it'll always be with an equal sign. So this is a common mistake that students will write that asymptote equation and put a line through it. We put a line through the equal sign when we're talking about a non-permissible value, but when we're talking about an equation of an asymptote, we don't put in a line through it. Okay, so step 1, factor. Step 2, look at your non-permissible values, determine if they're going to be holes or asymptotes. You can sort of start graphing off to the side. We now know at x equals 2, with an equal sign, no line through it, we have an asymptote. Step 3 was determining whether or not we have a horizontal or an oblique asymptote. Now, based on what we did yesterday, looking at this equation, this is the group 2 where you have the same degree on the top and the same degree on the bottom. When you have the same degree in your numerator as your denominator, you will always have a horizontal asymptote. And in this case, we have a horizontal asymptote at y equals 4. Step 4 was pick some nice points. One of the nice points that you should pick is your y-intercept. How do you find a y-intercept? Plug in 0 for x. If I plug in 0 for x into my equation, can you see that you would get 2 divided by -2, which is -1. So you would have the point 0, -1. You might also, here, just a reminder, nice points. Y-intercepts and x-intercepts. Y-intercept is plugging in 0 for x. X-intercept is plugging in y equals 0. And I want to show you something when I plug in y equals 0, so I have 4x plus 2 over x minus 2. Something about fractions. Does it make sense that a fraction, which I have on the right-hand side, is only equal to 0 if your numerator is equal to 0? That's the only way a fraction is equal to 0. And so you could show the work, oh, I'm going to multiply both sides by x minus 2. Here they cancel out. 0 times x minus 2 is just 0. That helps explain why. Or you can just look at the numerator and say, the only place that a fraction is equal to 0 is if my numerator is equal to 0. Solve this equation, bring the 2 over, divide by 4, and you get x equals negative 1/2. So we can label that point as well. When drawing your graph, if you have points and you have asymptotes, what do asymptotes show? Asymptotes show where your graph goes towards. So the fact that I have 2 green points in this section, I know those two are going to be connected. Here it has to curve towards the asymptote. Here it has to curve towards the asymptote. So as soon as you have points and asymptotes, you can just draw your graph towards the asymptotes in the appropriate manner depending where the points are. That being said, when finding nice points, you have to have some points in every section of your domain. Right now, do you see that we only have our graph when x is less than 2? We need to have at least one point when x is bigger than 2. So I'd probably choose 3. What happens when you plug in 3? My numerator, I'm going to get 14. My denominator, I'm going to get 1. 14 divided by 1 is 14. So on my graph, way up here, I'd label the point 3, 14. And as soon as you have that point, you can draw that whole section just going towards the asymptotes. So step 4, nice points in graphs, actually is quite involved. I'd always find my x-intercepts and y-intercepts as nice points. And then sometimes, like in this situation, you need to find another point as well. So a little bit different today, because when you get to your homework assignments, and the question for practice on this one is just number 5. And number 5 will say, only find the vertical asymptotes or the holes, but I do want you to graph it completely. So what we're going to do is we're going to go through all of the characteristics today and see and review steps 1 to 4 because they stay the same every single time, but we'll run into the different situations that we're going to run into. And then I'm going to give you time at the end to work on all the questions.